Welcome everybody to the November meeting. It's kind of a special meeting, a little historical in that when we do the Astro-Imaging Corner, we're going to be doing the 150th edition, or 150th edition. So we have a special presentation while we're doing that. And we have a couple of members who are going to be doing their presentation tonight. Being members night, we have two presentations. First one will be Alex Turner talking about space geodesy, the study of where and when. And then Luca and Alister will do a tag team on the major lunar standstill of 2024-2025. Okay, so we'll get Alex up here and he can start the presentation.
Yes, so I am Turner. I work for your provincial government as the geodetic lead. That is who I am. And I will be talking about space geodesy today. So, space geodesy, geodesy is a funny word. Now, geodesy, along with astronomy, they are the oldest of all sciences. Now, you might be thinking to yourself, why have I never heard of geodesy? If it's so old, and it is important, I think it is anyway, how is it that I've never heard of it? Well, if we break apart the word, geodesy is, coming from geo, meaning earth, and deci, to divide. The original name for geodesy meant to measure the earth. So if we take the earth plus to measure, we get, I must have not actually created that slide. Yes, we get geometry. So you have heard of geodesy. It's just, it became so useful that we lost our name. So here's just a nice graphic as to kind of the dependence and sort of co-relationship between geodesy and other sciences. It is, kind of fundamental sciences for all of your mapping and anything to do with spatial sciences, as it's laying out all the underlying foundations to relate spatial data to each other. But just from the very nature of it, as we'll get into a bit more tonight, a lot of your measurements end up being astronomical measurements because space is nice and stable compared to things on Earth. You can also see it over long distances. So astronomy is somewhat considered the sister science to geodesy, as well as geophysics. But you're also pulling a lot from atmospheric sciences, other space sciences, oceanography, and so on. Now, I don't know if you recognize this building. This here, just to give you a demonstration as to how geodesy and astronomy are linked together. This is Canada's observatory, astronomical observatory in Ottawa. It was founded by Dr. William F. King, who was Canada's first chief astronomer and the founder of the atmosphere or the astronomical group within the federal government. And him, along with Otto Klotz, are the ones who kind of got that going. And as he held the title of Chief Astronomer of Canada, he was also the Survey General of Canada and the head of the Geodetic Survey of Canada. So it was viewed as though with all of the geodetic measurements that were going on, it was starting to get to the point where, he could prove that yes, Canada needed its own scientific group looking at astronomy. Now, getting into some of the actual science of it. As you may know, our clocks are all based on the sun. Now, if you look at the sun in the middle of the day, that's where we base noon on. But if you were to observe this, if you were to observe that middle of the day every day, one of the other days, you're going to be offset. And so you'll get what's called an analemma. And this becomes quite a big problem if you're taking geometric measurements based on things in the sky. If the position of your stars, your sun, all of your planetary bodies are going to be different, you need to account for that. And that is where geodesy comes from. So geodesy is studying all of these different dynamics that go into it, which includes time and all that fun stuff. So we'll just go through some of the current space technologies that are in place right now that are going into everything that is used to derive the models, is used to get all of our orientations and make accurate measurements. So the first thing, and something Canada's somewhat lacking, is positioning of satellites and their orientation. We send a lot of stuff up into space, and we need to know where it is, where it's pointing. Something you may be familiar with is the most precise way that we can get the orientation of satellites is through star trackers, which are just simple cameras on the satellite. And as you may have done yourself, it's just a simple plate adjustment to figure out its orientation based on the known location of stars. There's also something called satellite laser ranging. So these are two that are stationed in Switzerland. And we do very precise, I think the precision is around within 5 millimeters. We measure the distance between the station to the satellite. And we track that as it goes overhead, and that gives us, the location of that satellite, but it also tells us more stuff. So, satellites follow the laws of orbital dynamics, but the gravity field's not consistent. So if you're able to measure the location of that satellite and compare it to the mathematics, that's going to tell you something about how the gravity field is differing from the models that we have. But of course, as you can see, with all sciences, there's always limitations. This is a big limitation here in Canada. We have no satellite laser ranging here. We are just as dense as most of Africa. And And that means this is kind of a big problem in that for your satellite applications, the performance is going to do far better in Europe than it is going to be in Canada because they can align the positions better over Europe. Now on to another aspect of space geodesy that you are familiar with now is GPS. So this is the second generation of GPS satellite. There's currently 32. Well, the GPS requires to have 32 satellites in orbit. I think they're currently running at 36 that are working. And then there's also the constellations of Galileo from the European Union, QZNSS from Japan, GLONASS from the Russians, Beidou from the Chinese, and I can't remember what the one from India is called. Now GPS, you might use it to navigate through the city of Edmonton. Unfortunately, traffic and construction gets in the way sometimes, but it's far more useful than you might think it is. Now, just the basic science of GPS, it's sending out a timestamp, and you receive that timestamp, and then it calculates the distance between the satellite and you. So if you have at least 3 satellites with a distance, you can calculate your location. But what's really, really useful is the fact that the atmosphere interacts with that signal. So once you start to have more and more measurements, a couple things happen. Number one is that you are actually measuring the atmosphere every time you are calculating a location with GPS. Another big thing is that it's determining what time it is. Because this is all just a time measurement, they need to be able to sync the clocks very, very accurately. And so all of your banking is now based on GPS because GPS is the most accurate way of determining time on the planet. Is that what I want to do? Yeah. Yeah, so GPS just ends up being the science of time. And even for positions, latitude or your longitude is just a measurement of your local time versus the time in Greenwich. I thought I'd just bring this up where you can actually describe all of your positions on the Earth using hour angles. So 24 hours instead of 365 degrees. But when you're trying to align your telescope, this is the value that you want to keep in mind, is that if you're doing any kind of star tracking and star alignment, if you're off by 1 second, you're going to be off by 15 arc seconds. So, I mean, that is one of the reasons why, people do integrate GPS into astronomy gear now. It's not just about where you are, but it's also about determining what time it is. Yeah. And Just to give you a reference as to how precise the timing from GPS is, the work that I'm dealing with, we can refine the position. We can refine your position on the globe to within about 5 millimeters. And because it's traveling, it's just electromagnetic radiation. If our clocks are off by 1 nanosecond, it means that those measurements are off by 30 centimeters. So if I'm dealing with 5 millimeter precision, you can imagine just how precise those clocks end up actually being. Now, another application of this, which is truly out there. If you're looking at the path that a signal travels from GPS to your actual receiver, and something occurs like an earthquake, or they set off a nuclear bomb on the ground, that actually compresses the ionosphere. And it changes the path of that signal. And so by measuring the difference in time delays, they're actually able to measure the location and magnitude of an earthquake or some other kind of seismic event. And that's actually how we know that they did nuclear arms testing in North Korea underground, was a GPS array in Japan measuring the ionosphere. Another thing that we care quite a bit about is the gravity field. Now, somebody may have told you that the Earth is flat. An interesting thing, Canada's most well-known geodesist was the person who created the Flat Earth Society of Canada. Now, he created that as a satirical group to make you challenge, yes, that the Earth is round, but have you actually ever observed that? Have you ever actually seen any proof that the Earth is round? And the only way to really do that is through astronomical measurements. Now, you're not going to send up your own satellite missions, but there are different ways of doing it. And to finish off that sidetrack, yes, the Canadian group was created as a satirical group, but some people in the US saw the name and they didn't get the memo that it was a satirical group, and they took it very seriously. So it's all our fault. Yes, getting back to the slide. So we do care about the gravity field, and the Earth is in fact not a very smooth object when it comes to gravity, because there's different densities in the Earth, and the Earth is very lumpy. So one of the ways that we measure the gravity field is through GRACE satellites. Now, how they work is that it is a satellite pair that's doing constant distance measurement between the two. They're not actually taking gravity measurements. What we're doing is that as the leading satellite approaches a mass, in this case a mountain, I must have deleted a slide again. So as it approaches a mass, that mass will actually pull it forward, and then that distance between the two satellites will get elongated. And then as they pass over, the distance will shorten again because they're both being attracted by that mass. And then once it passes, the trailing satellite will get pulled backwards. So these are just two satellites that just orbit in a non-consistent orbit. Just ongoing, and we're just tracking how they are changing their distance between them to measure the gravity field. This results in our model of the gravity, or model of the Earth, which we call the geoid. So if you were to reduce the Earth down to the same gravity value, and create a model based on where that value of gravity is to the center of the Earth, it would be a lot smoother than this. This is certainly an exaggeration of the differences. But, you know, the important thing is that there is a difference in distance from the center of mass of the Earth to achieve the same elevation. Now, this is something that really only becomes possible in the satellite era. In Canada, our heights used to be based off of tide gauges, which are not gravity values, because yes, you can take the mean level at a tide gauge, but ocean dynamics mean that there's variation between that. So before we go into before we really had all the satellite data, in all of our heights, water could flow uphill, which is not good. Now, what does that mean to the astronomer? Well, when you're setting up your telescope, you might have a little level bubble on it. That level bubble is going to be perpendicular to the same surface of gravity. And so really you're aligning yourself to the geoid rather than just this nice ellipsoidal mathematical model of the Earth. So if you really need precise alignments, you know, once you have your location, the geoid deflection and verticals need to be applied. Interestingly enough, this is how we also do several, you know, additional measurements of the gravity field by setting up a zenith camera and taking photos of stars. And based on the position of the stars, we can prove that the deflection is correct or incorrect. Another big thing that we're trying to deal with is the natural motion of plate tectonics. Now, plate tectonics is something that was proven here in Canada. Again, if you're dealing with, you know, the motion of plates, how do you determine that the North American plate is moving relative to Europe? The only way of doing that is through the stars. Yeah, well, here's just a bit better detail as to what's happening in Canada vertically. So not only are we moving horizontally, but we're also moving vertically. Mostly to do with isostatic rebound. So there used to be a big glacier over the Hudson's Bay. There's no longer a glacier. the land's moving up, our coasts are moving down, so Nova Scotia is sinking. Hudson's Bay is going up quite a bit. So although water levels are going up in the Hudson's Bay, relative to the land, the water is going down. And all of this can only be measured using space. So a lot of the measurements we do now are through GPS, but the most precise way of us measuring plate motion is by looking at quasars. This is the technology that was used in Canada to prove plate tectonics. So there's been a number of presentations that have talked about radio astronomy and very long baseline interferometry. From an astronomy standpoint, you know, you want to set up 2 radio telescopes and you know, your signal that you're getting from a quasar, you want to be able to align those signals and correct for the time delay between when they're receiving it. But from the geodetic standpoint, if you can take this signal and you can measure the time delay between 2 stations on Earth, you can measure distances to just an insane precision. So if we set up a VLBI antenna here in Edmonton and one in Germany, we could measure the distance between those 2 points to within 3 millimeters. And the only way is through space observations. But like many things in Canada, we invented the technique, and we had 2 stations, one in Yellowknife and one in Algonquin. But unfortunately, it was viewed as not being very important. And so the funding was cut, and we no longer have VLBI in this country, which is kind of a big problem because we're becoming more and more reliant on GPS positioning and being able to track the North American plate motion. We're very, very limited. And just like satellite laser ranging, you can see that most developed countries have put in the effort to ensure that they can make these measurements. But Canada is this big hole. Yeah, that's some of the stuff going on.
All right, if there's any questions for our presenter, just raise your hand. I've got a microphone here. We'll hand it around. Maybe I'll get Clayton to do that.
Hi, Frank. Anybody got any question? Oh, great.
Has anything involving your field been used to measure the gravitational waves that are being measured with lasers on a large scale? But can you use something like this to detect a gravity wave?
So this is one of those things where the relationship between astronomy and geodesy, you know, that time difference in VLBI, that's an astronomer's noise, but that's our measurements. The gravity waves for us, we're just trying to filter that out. So we're not looking at it. So within our field, we'd be trying to just eliminate that rather than trying to pull it out. Now it's not actually the work that I do, but I'd be very surprised if there wasn't that collaboration going on as, please, can you eliminate this from my data? And the astronomers are very happy that they have these measurements. going on.
Any other questions?
It seems like a very expansive field and very intriguing field, but what would you be doing on a daily basis in this huge field of that you work in?
Yes, so I'm with the provincial government, and on a provincial scale, we're not doing very much space geodesy. The application of all of this is defining coordinate systems. So anytime that you're using GPS for, lining out your property boundary, or for construction applications, you need to be able to align different data sets coming from different sources. And so I'm looking at all of the sort of rules that go into place as to aligning yourself to that reference frame. And it's a lot more of defining procedures and for actual survey practices. Yeah.
Any other questions? One online. One online? Okay, go ahead.
Oh, I think that's me. Thank you for taking my question. My question is sort of related to what's happening with COP30 in Brazil. And I had no idea how interrelated the satellites on the Earth were. I thought agriculture was really big, but I didn't realize what was going on, what you're describing. So the question is that when we think of environmental sustainability, it's about the ocean and the land. But in your experience, what do you think we need to do regarding space environmental sustainability?
Maybe a little bit less on sustainability answer, but one of the biggest problems that is out there when it comes to addressing environmental concerns is just lack of measurements. So, geodesy is all this science of measurements. And yes, it's a very expensive field. And there's just continuous cutbacks, and there's just a general lack of awareness. So, if you want to be making decisions to minimize environmental impact and to respond to environmental changes, people need to understand the fact that the gravity field is not this consistent thing, that the gravity field changes, that, there is all of this work going into aligning your data. And if you don't have good measurements that are aligned, then you can't actually measure the changes that are going on.
Okay.
So just a follow up. So you mentioned that, for instance, Canada isn't having these instruments on the ground to help coordinate with the satellites. So, for instance, if we invested in that, would that mean that we wouldn't have to put as many satellites in the sky? Because I heard that, and I'm not an expert on this, but if you the rocket fuel to send a satellite up, or to go to the moon, or to go to Mars, the pollution is what happens on Earth. So if we had better instrumentation on Earth, would that reduce having to put so many more satellites in the sky?
Yes, it can. So one of the things that we as a country are looking at right now is that because we don't have this way of supporting our satellite positions, The satellites that we are sending up into space, for example, RadarSat, are not going to be aligned and oriented as precisely as they could be. And so because of this, they do have somewhat more of a limited application. And so that has resulted in other satellites being launched in order to make up for the limited application of these satellites.
Okay. Thanks, Alec. Now I know what geodesy is all about. Okay, next up from our members night. We have Luca and Alister talking about the major lunar standstill of 2024-2025.
I believe Frank is queuing up the movie for us. In short, Luca and I have been working on a project for a number of years now, and it is called the Lunar Major Standstill, and the movie will explain what it is and how it appears in our sky, and then we will follow this up with a short back and forth as to why we even did this, or how did we even figure out that this was something interesting to do. So let's roll the movie first, please. And the cycle never ends. There's a PowerPoint deck. Stand still. Yeah. Okay. Okay. Oh. Okay, so the big question after the movie is, why did we do this? And where did the idea come from? Okay, is it the right arrow key? Doesn't seem to be. There we go. Oh, okay, there we go. Thank you. So why do we do this? Cycles. As many of you know, Luca is very fond of large visual projects that show the beauty of the sky, the cycles, the music of the spheres, how the sky rotates. He's done some very neat things, timescapes. This is during an annular solar eclipse. Especially that analemma here from Edmonton, showing how the sun doesn't quite keep time with the stars as we float around. And also for time slices, taking things minutes at a time on occasion. Also space slices. This was a very interesting project that Luca did with photographers around the world, capturing sunrise on the same day, but from different latitudes. Longitude. And longitudes as well.
And Alister, like Stonehenge style alignments, and sky watching in general. He likes geometry, the reflection geometries of sunlight and moonlight off of buildings. Also skyscapes with usually Edmonton in the foreground, whether it's partial moons, crescent moons, or full moons, and basically these time slices showing the changing color of the moon, and then reflections of sunlight from various vantage points. And then finally, a lot of full moon type shots low over the Edmonton skyline.
And one of the things that came out of our various collaborations, and sometimes we were just shooting side by side, is while we would converse, we both tended to agree on a very similar philosophy where we like to represent in our images what the sky looks like to the eye. So none of this fakery that comes out through that. This is not fakery. This is as it was. And so here was the seed was planted as we were doing an all-night event, watching the moon go across from the southeast to directly south and to the southwest. We're on the top of the parkade at the Royal Alex, looking south. And at this time, we were talking about the upcoming lunar standstill, but among the things was, this is a neat dry run. In a couple of years, this arc is going to be even lower in the sky because the moon's declination is going to be increasing. And so we'll get this neat kind of thing where it's even lower. And I think that planted the seed in Luca's head.
Right, and that was percolating in my mind for quite a while, and then a year or two later, I did this Year of Sunrises timescape showing the progression of the sunrise point from the northeast through to the southeast over a 12-month period, and that got me thinking about, well, this is where you can capture the actual movement of the sunrise position over the course of a year. And well, yeah, we're coming into that major lunar standstill. It's coming up. And so I thought we should try and capture this, but there's a lot going on, not just the movement of the sun, but also of the moonrise. There's highs and lows. The highs become higher and the lows become lower. And the farther north and farther south things will go, especially with the moon going past the extremes of the sunrise points. And so doing a series of all-nighters to do all of this was going to be way too much. And I said, well, can this be a movie? Can we do it can I do it as an image? Can we even tell the story in one image? This particular image led me to think that we probably could. And then Alister piped up. He says, well, I hope you're not talking about an 18-year project, are you?
Yeah, because of course the whole cycle is an 18-year and a bit. And one of the things that shows up, of course, on various places across the internet is the path of the sun or moon in the sky. Midsummer sun goes up high, midwinter sun is low. And of course, you've got the wonderful Stonehenge thing and all these different arcs and a nice little diagram here. And just, well, we could easily do this, just talk about these three diagrams and we'll be done. That's it. Nice short project, just one little night of talking about it. And then, of course, well, that wouldn't be any fun, would it? We have to make it more realistic. And as we're going through all of these sort of discussions, we inevitably see image after image on the internet of things that are just like, okay, it's art, but that's not how the sky works. And the image of the moon is way too big for the view that you're getting here. And so it's just like, well, let's really try this so that it fits with our philosophy of, hey, if you were standing here with us looking at this event, this is what you'd see. So then became, how do we shoot this? And so Luca had already started at with a near fisheye lens. Okay, we can do this for the sun. Can we do this for the moon? Can we shoot wider and get it all in one shot with one lens? And we talked a little bit about this. And to me, the problem was, well, if you go fisheye completely in order to capture this, well, there's a left shot, fisheye view of my backyard. And if you zoom all the way in, this is the view you get of the moon, not exactly what you would see with your eyes. And so we then sort of talked about, okay, how do we represent this so that at the end in our image, we can see the face of the moon?
So I suggested, well, why don't we do it with a couple of wide angle panels that are not fisheye and then stitch them together in a panorama, right? And now I think you've been doing some good work with Hug and you're pretty comfortable with the Hug and stitching software. So we just stitch, we project, and here's a couple of test panels I shot one time, and Alister put them together in a panel. Well, there you go. Everything's cool. Very easy. Ta-da, there's your wide angle panel, fully formed and beautiful. So, okay, this means we can keep the size of the moon fairly big. And what we're going to need to do, because this is going to take quite a while to capture all these images, is we're going to need a checklist and we're going to need a procedure so that, because I wasn't going to take all the photos, Alister wasn't going to take all the photos. So but we have to do it the same way. So we made this checklist and promised to actually follow the checklist, not just get into the habit of, oh, I know the checklist and not actually look at it. And then we could just assemble everything together with Huggin, and Bob's your uncle will have this great project done.
And of course, what you don't see here is the checklist goes beyond the bottom of the frame here.
Right.
It keeps going because, yeah, you really don't want to mess up. So what could possibly go wrong? Well, the stitching software works great if you're working on single panels or single events. Boom, you've got a nice cityscape. Doesn't that look nice? And then we lined it up with another night and just like, this panel is, 11,000 pixels across, and the other panel is 11,200 pixels across. So the scale isn't quite right. It's like, well, hey, easy enough in Photoshop and GIMP. You just rescale it, rotate it a little bit to help make sure everything lines up. So we go through all that, and only later on do we realize that the very center of the image, because we've lined up the edges perfectly, we've scaled it perfectly, the middle is offset. So here are two images with partial translucence to show the differences. So this one was differences only up and down. Other ones had slight differences side to side, even when one building on the left was perfectly centered and the other building on the right was perfectly centered, but the middle wouldn't be. And so we had to do a little bit of manual processing to transform, warp the image to get it to line up just right. Because as you go into these long, beautiful streaks of swoops that you saw in the movie, things wouldn't line up. And that is really jarring. So what else can go wrong? Well, the cameras don't work.
You get a
Oh,
at the end of the problem.
it shouldn't be. There we go. I'm pushing the wrong button. Sorry.
Okay, yeah. So what could, so clouds? What clouds?
I thought at full moon it was always clear.
That's right. It's always a full moon clearing effect for clouds. But actually, the work that I've done on sunrises over the years, it kind of demonstrated to both of us that, you can actually get 13 sunrises in a row in 13 months, in 12, 13 months, no problem. But moonrises are a different matter because we didn't really have any leeway in terms of the full moon dates. We had to capture them on the full moon dates because otherwise the moonrise position just changes too much, even by one day. So, so if you're imaging full moons and you want to do a sequence for several months in a row, that's just not going to happen. And we figured we would get 40% clouded out. And so then was the question of, well, what do? We just put a blank, take a shot of the blank sky, like that cloudy one you just saw on the previous slide, and just plop in any moon? And that would be too close. That would be crossing a line for us, too close to basically cheating. And so we thought, we have time leading up to the actual standstill because we started this almost 2 years prior to the center of the standstill. I said, well, we can look at moonrises that are going to be very, very close to the targets in terms of the position of the moonrise and even the skylighting conditions. And so we said, we'll grab as many of these proxies as we can and use them if we have to. And in the end, it turned out that we were clouded out on 8 out of 13 moonrises. And this is a collection of what it would have looked like. This is the moonrises, the actual 13 that we shot. And you can see on some of them, there was just no moon whatsoever. So we had to got one there. Yeah. Well, there's only 5 with the moon. The other 8 we had to use proxies for it in the final composite.
Yeah. And the part of that sort of philosophy is, had it been clear, this is what you would have seen. And we really did not want to resort to outright fakery. And the other thing that we wanted out of it as well is, well, when we're done with this project, we're going to have this wonderful array of images, and this is something I want a poster of. And if we're going to blow it up to poster size, we need to be able to see what the eye sees. So a moon with a little bit of detail on the face, the buildings that you can see if you were there. And the wonderful thing about this type of project is collaboration. So
That's right. It makes it more fun and less of a slog having to deal with all of the issues, and also being able to alternate the work of actually capturing the images when somebody wasn't going to be in town and things like that. And so we're really proud of the image that we did create, because not only is it nice to look at, but it's also quite educational in terms of describing and showing that the moon in the major standstill does rise at the extreme points further south and further north from the sun. And as Alister said, had it been clear and you watched every one of these events, you would have seen something like what the final composite shows you.
And we were also very pleased that it got chosen for an APOD, Astronomy Picture of the Day. And we also have an article coming up in the Journal of the RASC, but also we got a Petapixel article from the work that we did.
And if you want more details on the project, you could read this month's Stardust. That'll give you the full background about everything we've talked about, as well as a link to the movie on YouTube, which is an extended director's cut. There's some extra behind the scenes stuff if you want to see, especially the business about the proxies that we had to deal with, and they're all shown in a coda to the movie.
And those of you who have a head for orbital geometry and that kind of thing, there are also sort of Easter eggs hidden in plain sight in our full panel here, where you can look at the brightness of the sky, the size of the moon. Did any of you notice that the supermoon in there was that much huger than the
13%
mini moon?
larger than, yeah, that's right.
So there's actually a lot to see that you can pull out of the image.
There's even a little bit of Edmonton's changing skyline. In a project that takes several years, you're going to see things pop up.
And trees growing.
That's right.
Yeah. So it was a wonderful project to work on with you, Luca, and look forward to more interesting projects.
And we leave it to the viewers to contemplate doing the minor lunar standstill in 2034.
Standstill, yes.
Thank you.
Thank you.
I have one question. What day of the month did you determine to do your photography, and what made you choose that day each time? What day?
Well, we knew that the major lunar standstill was basically centered more or less around December 24. And so we chose, let's start at the solstice before to the solstice after. And our target dates for shooting was to shoot the day of the full moonrise, because that's the biggest disk. It's going to be the most easily seen in the photo. So the target date was 13 consecutive full moonrise dates, with the sunrise taking on that day or a similar day to represent the ground conditions and the sky conditions.
Yeah. You could also do it with first quarter moons all the way through, but full moons seem to make the most sense as they have the most visual appeal.
Great, thank you. Any other questions for these gentlemen?
How many photographs did you take?
How many photographs did we take? I think, Luca, you probably have the number closer in memory than
I don't have a count of the photographs we took, but we shot 53 events.
Yeah, 53
We
events.
shot 53 events, most of them proxies.
So, yeah, each event, 2 panels, each sort of shot was a burst of 5 images, so that we could properly expose both the moon and the foreground city and combine them. So there's a little bit of stuff that we didn't talk about here.
It was largely just a few dozen shots per event. You didn't need a lot. The sunrise, just as it came over with the glow, that's when you had to capture it, and that was it. And for the moon, we were always waiting till 2.5 degrees altitude, just so that you could see it and it would be bright enough to see, not obscured by buildings and bright enough to see. So we would do bursts at 1.5 degrees, 2 degrees, 2.5 degrees. Because sometimes clouds were slightly in the way, not completely obscuring. So it's like, okay, well, this was only 2.1 degrees altitude, but if we wait till 2.5, the cloud it'll be covered. So there's slight variations, but only a few dozen pictures per event, and we did 55 of those or so.
Yeah, and we knew that wildfire smoke can obscure things significantly, and that's another reason we wanted to wait for the moon to be that little bit higher than the sunrise, because the moon's got to punch through all that smoke too.
Yeah, one of the targets is in fact a smoky moon. It's red. If you look at it closely, it's a smoky one of them for sure. And one of the sunrises was also not quite as smoky, but the sunlight's the one where the glow is the least on the sunrise. That's a smoky day as well, because it was attenuated by the smoke in the morning.
We have Linda online to ask a question.
Sure, go ahead.
Hi, I wrote in the chat that besides educational, it's breathtakingly beautiful. So kudos to all your hard work. My question is, I have been to some of the ancient sites where the agrarian cultures, ancient agrarian cultures, did all the things charting the sunrise and the moon. And my question is that in doing this, without knowing all that you know about how the solar system works, would you have figured out that maybe the Earth revolved around the sun, or it's not evident? It took that moon wobble, or sorry, Mars wobble, to help the scientists figure out that things weren't quite what they thought about the Earth being the center of the solar system.
Interesting question. I mean, I'm in awe of the Babylonians and ancient Greeks who are so persnickety with their record keeping to be able to figure out the cycle of the eclipse patterns. And those things, just from one eclipse pattern to the next element, one Saros to the next 18 years and change. You need really good record keeping, and you need to make sure that the people that you mentor keep up with the work that you started with. And I'm just in awe that they were able to do all of this. But one of the things that we also just wanted out of the project was this ability to look at the sky. Would I see this kind of thing? And it's like, oh yes, if you have a Stonehenge, or at least a small cairn of rocks, you'd be able to go, wait a minute, the moon's never been that far over. But then you have to do the follow-up of, oh, let's actually make a measurement.
Thank you, gentlemen. Very good. Very interesting. Job well done. Alister, can you do the observatory?
Yeah, Frank, if you could pull up the following PowerPoint, please. So the observers group is just a bunch of people who get together to go looking at this stars. And here we are. We've got an in-town small group session for tomorrow evening. We're going to be at the U of A farm, just on the north side of 62nd Ave. And there we go. And you are all welcome. Hopefully not all of you will show up. There's not much room there, but there's certainly enough room for a few cars. Bring your telescope, binoculars. It's all about learning how to better see the sky and what's up there. So somewhere, click. I am pushing the right button this time. There we go. Catching up. When we get together, it's very ad hoc, very short notice. For example, I put this notice out for tomorrow night. I first put it out Sunday. As you know, the weather changes pretty quickly. We want to try and minimize the amount of false notices that go out or cancellations. but inevitably that happens. But the idea is just look through telescopes that we set up, look through binoculars, and sometimes we get a little bit of cloud, but tomorrow night we should be pretty good. Things to keep watching out for. We're still waiting for the outburst of T Corona Borealis, the Arcturus, and then up to Corona Borealis. Hopefully that'll happen, and it's something that anybody can see from even in the city. One of the upcoming events is the Leonid meteor shower, and we're in the torrid fireball season. So hopefully in a number of days, we might have a good enough stretch of weather that we can join up together out by Black Nugget and watch some meteors out under a dark sky. It is not, despite all of the wonderful advertising and media hype, it is not going to be a storm of raining down of fire from the heavens. The Leonids are expected this year to be a fairly classic non-storm, 20 meteors per hour. So if you sort of divide that up, it's just every few minutes you're going to see something, and it's more than likely going to be just one of these little whoop, and there it goes, and it's gone, and you've got another few minutes before you see the next one. But it's still a wonderful way of looking at the sky. And also, just for fun, under a dark sky, you should be able to see the planet Uranus just with your straight eyes, as long as you know which little dot, not too far from the Pleiades and the Hyades, which little dot is our planet. So that's what's coming up with the observers group. So thank you very much.
Thanks, Alister. Okay. So Frank, if you can get the trivia questions up, and we'll get those up, and then we'll just take our break. Okay. So, what's the only planet not named after a god? What is the coldest place in the universe? Which planets do not have a natural satellite? And what is the unit of measurement used to describe the expansion of the universe? So we'll take a look at those after the break. So take about 5-10 minutes and we'll get back at it. Okay, everyone, and if we can get back to our seats, we'll get going again here for the second half. Hey, Frank, if we can get the announcements up. Line item 6. Okay. I'm going to get Chris Mervell to come up here. We just completed Jasper Dark Sky Festival for this year. And we'll do a quick recap. And then I'll get Kent Martin to come up and give us a quick update on the Planeway project.
Thank you, sir. This year's Jasper Dark Sky, there was good news and bad news. I guess the good news was that we followed it over the past year. We've had some serious negotiations with Parks Canada and the town of Jasper about our role in the Jasper Dark Sky Festival. They just saw us as another vendor, and we had to convince them this year that that wasn't the case, that we were a partner in them trying to achieve dark sky status as well as maintaining it. And they've come around a long way, and they totally changed things around. They put us back in the dark sky at Lake Annette. They had shuttles ready for us to take there. So that was the good news. They really treated us well, and the way we hoped that we would be seen. Unfortunately, the weather did not cooperate. We had no dark sky. We had cloudy sky and rain, and so we had 10 couples. No, we had 11 astronomers, and most of them were couples. So they were husbands and wives, and a few individuals. Unfortunately, we got relegated to the historic fire station, where we set up telescopes and had audio visuals and so forth, in lieu of being out in the dark sky. We were very, very crowded at times, to the point where you could hardly turn around, which was good. We could promote why we want dark skies, and one of the nice things was we were paired with the nocturnal animal people for one night, who saw us as partners in their quest for dark skies as well, and that was rather interesting. Clayton and Jay had a meeting with the town. They invited us to lunch, as a matter of fact. They wanted to reinvest in the dark sky program, and we could tell they were serious by the people. They had people from Parks Canada, from Tourism Jasper, but the most important person I thought that was there was an engineer that was responsible for doing a lot of the coordination and purchasing of light fixtures and so forth, and other things. So we could see they were serious, and he was very intrigued about finding out more about our ability to supply them with people that could supply the equipment and programs that they could use. They want to make the town of Jasper dark sky preserve. Right now, it's sort of a unique situation where Jasper is not part of the dark sky, but is surrounded by Parks Canada, which is the dark sky. And but they want to become a dark sky preserve as well in town. So we have decided that we're going to meet on a quarterly basis, hopefully, to move this program forward between the RCAB, or between the RASC and Parks Canada and Tourism Jasper. So I think that's a very positive sign, and I think we're going to be moving forward on this. They are somewhere the word came down that they are going to become a dark sky and work with us to get that designation. So I think that is a very positive thing for us and for Jasper. Thank you.
Thanks, Chris. Well, just to follow up on that a little bit, between RASC Edmonton and the Tourism Jasper, Parks Canada, and we will be setting up, we're going to put a committee together that's a joint partnership, and we will meet basically on a quarterly basis and work out a plan to get them their urban dark sky designation. Okay. We have Kent Martin going to give us a quick couple-minute update on the Planeway project. I think something's been going on out there.
Thanks, Clay. A lot of big stuff happening for us. I wasn't expecting to be speaking tonight, so I don't have anything audio-visual prepared, but the progress we're making at the Black Nugget Lake, the Planeway Observatory, all the red tape stuff is up to date. The screw piles have been installed. The concrete's been installed. We are going out on Wednesday, a smaller group of us, to shovel. If anybody's keen on getting that sort of exercise, please come out. We're shoveling to backfill the concrete foundation for the observatory. We're well into the systems planning. We have pretty much identified all of the components and the layout of the digital domain, the information technology, the control systems, and found that we have pretty much got things nailed down according to what we're able to establish at the moment. And we're about to purchase a weather station. Jay Lavender has built a lovely all-sky camera for us. And sometime over this winter, sooner, hopefully, rather than later, we'll have both of those up and they will be available online. So anyone who's interested in using BNLO as an observing site will have that information online. So that's what I have so far. Thank you.
Thank you, Kent. Okay, book of the month, Rosemarie. She pulled a fast one on me here. The initial book that I had the slide made up for was decommissioned. That book is no longer going to be advertised tonight, but she has what I consider probably a very good backup.
Thank you. I'm not going to take the blame for that. I have a co-librarian and he and I seem to maybe not click all the time. In any event, the book today is his choice, even though I'm the one that's presenting it. But before I do that, just a brief library update. The library is now available again for lending. We have about a catalog of about 700 books, 70 of which are missing. So that's a lot. They have a home here. Please bring them back. The library has been rearranged with new subject headings, which hopefully you will find it easier to find what information that you are looking for. And those subject headings are posted on the wall inside the library. The book that Mark chose is Final Orbit by Chris Hadfield. And it's a different book because it's fiction. Chris wrote this is his third book in the Apollo Mystery Series. And I've read the first two. I haven't read this one yet, but they're really interesting murder mysteries based on his life and his experiences. So I will just read you the jacket. Houston, 1975, a new Apollo mission launches into orbit on course to dock with a Russian Soyuz craft. 3 NASA astronauts and 3 cosmonauts joining to celebrate a new dawn of Soviet-American cooperation. But as NASA flight controller Kaz Zelemakis listens in from Earth, a deadly accident changes everything. Meanwhile, from a remote location in East Asia, the first Chinese spacecraft secretly launches. On board is China's first astronaut, whose mission puts him in a collision course with the Apollo crew. As Kaz races against an enemy on the ground and for answers beyond the sky, the safety of the remaining crew hangs in the balance. Full of intrigue and real history, including the fascinating story of Professor Qiu Sen, the father of Chinese rocketry and founder of China's space program, Final Orbit accelerates to a thrilling conclusion that captures the beauty and terror of survival 270 miles above the Earth, as only could be written by one of the most experienced astronauts alive. So I hope someone will come and take out the book after the meeting. Thank you.
Thanks, Rosemarie. And I've also read both his first 2 books in the series, and this is the third one. Continuing on with the protagonist in this. Good. So anyway, let's get on to Astro-Imaging Corner. Very special event for tonight. the 150th edition of Astro-Imaging Corner. And Tom Owen will be one of our presenters here, but I think we're starting off with Luca to get it going. And then Tom is down in Mexico. We're hoping he's online.
So I am online. Can you hear me?
Great, Tom.
Yeah, so I'm going to start things off with an introduction, but then I'm going to ask my co-presenters, Luca and Abdur, if they'd like to add anything to the introduction. So I'd like to welcome everyone to the 150th edition of Astro-Imaging Corner. Previous hosts, Abdur Anwar, Luca Vanzella, and yours truly, the current host, decided to team up and present a selection of images from the past 150 episodes of AIC. The years were divided up among us, and the criteria was threefold, and it could be that there's four or fivefold. I'll let my co-hosts add to it if they want to. First was to pick one favorite for each year. Secondly, no duplication of images. And third, no duplication of imagers. And so each of us took a set of years, and each of us will be commenting in turn on the images that we selected. Needless to say, it was a tough task. And by way of a general defense of our selections, favorite, of course, does not necessarily mean best. And indeed, there was something to admire about every single one of the images that have been submitted over the years. Before we get started, I'd like to acknowledge previous hosts of AIC who aren't with us tonight: Massimo Torri, Alister, Ling, and also Dave Mussel, who's agreed to pinch hit on several occasions. Putting an AIC together every month is time-consuming, but like so many things we all do for the club, it's a labor of love. Abdur, Luca, is there anything you'd like to add by way of an introduction?
No, that's very well said, Tom. I just want to say it's an honor to present alongside you and Luca today. So looking forward to it.
Very good, Tom. Very good overview of this tonight's special presentation. I'm just glad to be part of it with you too.
All right, so I'm going to. Anybody see that?
Well, you can see you right now.
Okay.
Have you shared your screen?
Oh, there we go. I'm looking for the share button. Okay. There we go. Can we see it now?
Yes.
Okay. So we'll go to the first image. I think we can. Come on. Oops. All right. So Luca, you picked this one. Maybe you'd like to talk about it.
Right. So we go back all the way to 2009, which is when Astro-Imaging Corner started. And one of the first deep sky objects that was presented at AI Corner was this excellent shot of the Andromeda Galaxy by Wayne Malkin. And of note with this image, he acquired all of the data in his backyard in Riverbend under urban conditions. So he had to go back deep into the archives to get me the notes on this image. FLI 8300 monochrome camera on a Takahashi 106 scope mounted on an astrophysics GTO mount. So this image here, which I thought was outstanding at the time and has since stood up well against all the other images we've ever seen of the Andromeda Galaxy, and there've been plenty. This represents 4 hours of total exposure, 2 to 3 hours in luminance, and about 20 to 40 minutes in each of RGB filters. And then later he added in some H-alpha narrowband to enhance the detail, processed in Maxim DL and finished in Photoshop. And I thought this is one of the iconic images, and it was from one of the very first presentations ever done on AI Corner.
All right. So thank you very much, Luca. It was a beautiful image of Andromeda, and you're right. I think we've all taken a crack at Andromeda over the years. I know Abdur has produced some excellent images. I've tried my best. And it's not the easiest subject in the world. We all know that. So it was a great image. Abdur, you picked Mark Zalchik's image for 2010.
Thanks, Tom. I did. So the reason I selected this one was because it captured two different kinds of interesting atmospheric phenomena in the same image. And, in Mark's words, this is an image of that wild NLC and aurora display from the night of June 2010. And the whole pairing came about rather suddenly, so Mark had to scramble to get the camera set up. And it's pretty rare to get an aurora overlapping an NLC display, let alone appearing in the same part of the sky. And this field also shows the legs of Ursa Major and the constellation of Lynx. So I thought this was, I guess, a good image that combines both NLC and aurora, which is quite rare. So I thought this would be my selection for 2010.
Excellent. So this was my selection for 2011. This is the moon in downtown Edmonton by our Luca Vanzella. And as you can see, it was an APOD. And over the years, Luca's earned quite a number of APODs, bringing honor and glory to the center in the process. His work is well planned, it's inventive, and it's eye-catching. And I don't know, Luke, if this was the first of your APODs, but it
Yes,
is
it was.
yeah.
Yes, it was first.
Excellent. And so I see this as a moody and moony rendering of our home city.
Some people on the APOD commentary at one time could sworn that it was a still frame out of Blade Runner.
Like, and that was that it could have fit right in with that movie. Okay.
All right, so I selected this image for 2012, an image of the Horsehead Complex. The Horsehead Nebula is an often imaged deep sky object, but this wider field captured by Eric Solomonson, that also includes the Flame Nebula, Alnitak, and the surrounding deep space, I think, to me, is among the finest. So much so that we actually use this particular image as the cover for one of the versions of the center brochure back in 2016. Eric captured this image from Morningside, Alberta. It's 4,482nd LRGB frames that he captured on December 31st and January 1st, 2012. So this was his New Year's celebration, I guess, that year, on a QSI 583 camera, Teleview, and 101 refractor on the Lost Mandy G11 mount. And he finished it, he processed it in Maxim DL with final adjustments in Photoshop.
Thank you very much. Beautiful image. And another very popular target of astro-imagers over the years. Abdur.
Okay, so this was an excellent image of Jupiter from Freddie Williams. And the reason I selected this was partly because most of the images we receive are of deep sky objects, and images of the planets that show significant detail are very hard to capture and very rare with the seeing we usually get. So Freddie had captured this from Hawaii with his C14 Edge HD, or just Celestron C14, not an Edge HD, but in 2013. And I had selected this because of the phenomenal amount of detail you can see here. And this was an RGB composition along with some infrared data added in for some extra detail. And you can see the great red spot, and of course you can see the cloud belts and just tons of little festoons in there that I've maybe observed once visually. So this is just packed full of data. And he had used a DMK-21, which was an old, I think early CMOS camera, and a Teleview 2X PowerMate, and also RGB, Astrodon, and Astronomic IR742 filters. Freddie said it had been ages since he had gotten some good seeing, so he was processing some data from his backlog of data with better seeing. And I think he definitely accomplished that, so that was the reason I chose this image.
Yeah, it's phenomenal. I we tend to think, oh, well, the technology is so great today. I mean, nobody could be taking pictures the way we take pictures today. And then you look at something like this and it kind of makes you humble, doesn't it?
Sure does.
All right, let's carry on. So this is Franklin was this is a supernova in the cigar galaxy, of course, and Franklin Lodi was a longtime member and pillar of the center. And in fact, we have 2 awards named after him, the Franklin Lodi Award for Project of the Year and the Franklin Lodi Youth Membership Award. Remote imaging was still pretty novel in 2014, but Franklin was an eager adopter. And, he was getting on and he wasn't able to get out. And so he was using the SLU camera and downloading the raw data into his cell phone and then processing it on his cell phone. And he actually gave a seminar or 2 about how he went about doing this. And, a supernova in the cigar galaxy, that was a signature event in 2014. And then in this way, Franklin was able to show it to us all. And he said, despite horrible conditions on the Canary Islands and poor seeing conditions, I managed this 4.5-minute shot of the supernova tonight. Very little image processing could be used using the SLU humongous telescope, is the way he put it. And capturing these kinds of almost, you call it ephemeral phenomena, is an important part of astro-imaging. And so I thought this was a worthy image for 2014.
Thank you, Tom. Over the years, a lot of many pictures have been presented in Astro-Imaging Corner featuring the aurora. And when I came across this image, I stopped for a while and thought back to Bruce McCurdy, who was also a long time member of the club and also another pillar of the club. And he was a very avid watcher and reporter of the dynamic night sky. He often reported on naked eye observations or binocular observations of many things on his evening walks that he would post to the Astro List. And he often also posted skyscapes of auroras and NLCs. And this one really caught my eye because for a brief moment in 2015, at one of the displays, the aurora briefly took on the resemblance of the North American continent. And in this one, which I think he was, Bruce was a sky shooter. He wasn't really a deep sky processor, but this one here managed to capture all the various colors that the aurora shooters strive to catch. And I just had to stop for a while and contemplate and remember Bruce and his many postings describing to us the beauty of the night sky.
Yes, well said, Luca. We all miss Bruce and we miss Franklin.
Okay, so this was an image for 2016. This was Alister Ling's capture of Patricia Lake. And the reason I selected this one was that it just perfectly captures the ambiance of a cold winter night out in the mountains. I find that myself, at least sometimes when I'm looking through a telescope or I'm doing astrophotography, I'm just focused on a tiny little part of the sky, and it's easy to forget the big picture. That's ultimately what it's all about for me. So I think this image perfectly captured that, and I love spending time in the mountains when I can, and I always strive to just see scenes like this when I can. And you can see the constellation of Orion just behind the clouds there. So I think this was my selection for 2016.
That is a beautiful image. So, learning my craft in the 2000 teens, I always considered Rick Bram shooting with his Canon camera to be the knee plus ultra of center astrophotographers. And In 2017, many of us journeyed to see the total eclipse. And of this image, Rick writes, this was taken with my Teleview NP101IS scope and Canon 6D modded camera. Totality and its beautiful corona were captured using 11 different time sequences, 111 or 11 f-stops. I merged this composite with Susan's fast time exposure, showing the beautiful solar prominences. Susan used a Canon 7D with a 200 millimeter zoom lens and a Canon 2x extender, 2x extender. Workflow included using Photo Matrix and Photoshop. And really, there were a lot of images that came out. I took a couple. I'm sure everybody tried to get a couple, but this is a really outstanding image. So this is my selection for 2017.
Excellent choice, Tom. That rivals any of the really high dynamic range shots that we ever saw of the 2017 eclipse.
Yeah, it's got everything.
Yeah. For 2018, I chose this shot by Alan Hobbs of the Milky Way. So he took this picture at the Northern Prairie Star Party in 2018. And this photo not only features the Milky Way coming down into the southern horizon there, but also shows Mars as it was at its brightest that year. And I just loved the way the reflection of the night sky and the still waters of Black Nugget Lake. It really spoke to me as a skyscape. Alan tells me that he submitted this photo to the National RASC office as an example of light pollution. So as a light pollution subject, because it has the bright yard light at the campground office. And it's also a bright yard light that Warren Finley and I know can sometimes destroy telescopic views, but that's another story. And the Camrose light dome in the shot. So there's a dual purpose image that Alan did with this one. And he shot it with a Canon 6D, 14 millimeter Rokinon lens at 2.8. It's basically a 20-second exposure at f4 on a tripod. That's the kind of shooting I do, fixed camera on a tripod. And he processed this in Photoshop. Just an excellent skyscape in my view.
Oh, that was a beautiful shot, Luca. Okay, so I also chose a wide angle shot for 2019. And this is from Josephine, and I selected this because of the creativity factor in this case. And the image captured the Earth's rotation, some aurora near the horizon, and multiple satellites going through. And it just does an excellent job of demonstrating the rotation of the Earth. Normally, we use our equatorial mouse to try to counteract the rotation so we can get our long exposure images. But if you think outside the box, actually capturing the rotation itself can be a really interesting project.
Yeah, I admire Josephine's work. And I've said it before, she's very self-effacing, but she has a solid photographic background, and it really shows up in her imaging. So I picked this Murray. Of course, we all know Murray. Murray holds the distinction of having been awarded RASC imaging certificates in all three categories: deep sky, solar system, and wide field. And I really enjoyed this montage. It's instructive and it's also detailed. Mars is always rewarding to image. And 2020, as I recall, was a very good year for imaging Mars, and Murray took full advantage of it.
For 2021, I selected this nightscape that Warren Finley created during an event that he dreamt up and I participated in. But he shot this on March the 10th, 2016, and this is at about 4:30 in the morning during a break in his in the bi-marathon on Maui. I was there doing my own Messier marathon and guarding our equipment while Warren was running. But I especially like this nightscape because it not only shows the classic arc of the Milky Way, but it also includes the human element, namely the visual observers that were also there admiring that very same sky. So this was taken on an Astro-Track tracking mount with a Canon 6D and a Rokinon 12mm lens at f2.8. It's a single capture, 2-minute exposure at ISO 3200 and remotely activated flash to light the astronomer in the background and some minor processing and Photoshop. I also liked it also because it was a memorable event to try and do a Messier marathon and get it done in one night. And of course, Warren it beautifully captures that he could actually still get down on that stool after running. He'd almost finished running a marathon that night, and he could still get down on that stool with his burning legs and pose and sit there for the length of the shutter was open for this shot.
He could have been a biathlete with all of that. Okay, that's excellent, an excellent shot and a worthy object. So.
Okay, so this next image is from our very own Tom Owen, and I didn't just select this because Tom is a friend. I selected this one because Tom managed to capture just the excellent dynamic range of this galaxy. You can see the faint outer halo of stars, and then you can see the core, and around the core you can see all of those beautiful hydrogen alpha regions, and those are all large star-forming regions, all nebulae, like the ones we see in our own galaxy, and they look like fireworks around the galactic core. And this is, of course, Messier 94 in the constellation of Canes Venatici, 16 million light years away. And Tom said the image shows the inner starburst ring and the faint halo of the outer arms. And this was captured on April 23rd, 2022 at Pigeon Lake. And Tom used his C8 Edge HD at f7 and his QSI 683 camera. And this was a total of 118 minutes of exposure time in LRGB using 3-minute and 2-minute subs. And this was stacked in APP, which is AstroPixel processor, and processed using Star Tools. So excellent shot there, Tom.
Oh, thank you, Abdur. So images of the Orion Nebula have been frequently submitted to AIC over the years. I was surprised that the first image of the James Webb Space Telescope wasn't of Orion, because it always seems to be the first image that we all try to image when we first start doing astrophotography. And here's a beautiful example from Dave Mussel. Dave writes, "For imagers and visual observers alike, when Orion rises in the early winter and presents itself in the south under a clear sky, resistance is futile. This image was composed from narrowband data using a modified HSO Hubble palette from 188 2-minute exposures taken on the night of November 22nd, 2022. It was submitted to AIC in February of 23. The camera was a QHY 268M, and the telescope was an Explore Scientific 127 ED APO, reduced to 666 millimeter focal length with a 3-inch focal reducer / corrector. The processing challenge with the Orion Nebula is dealing with the extreme difference in the brightness of the trapezium region compared to that of the dimmer outer regions. This problem was addressed in PixInsight by using a series of selective masked stretches to preserve the trapezium region while raising the brightness in successively wider regions of the nebula and the surrounding Orion molecular cloud. So I chose this image not just because of its quality, but also because of the quality of the accompanying notes. Dave's notes are a mini seminar on imaging the Orion Nebula, and we appreciate great notes at Astro-Imaging Corner. So it's just terrific.
Okay, so what we have here, this is from 2024. On the left is an image of the Able 2218 galaxy cluster taken by the Hubble telescope, which has a mirror 2.4 meters in diameter, and that photo is taken from orbit. So none of this pesky atmosphere to deal with. And on the right is Abdur's image of the same field taken with a Celestron 11 telescope, which has a mirror 280 millimeters diameter. And that telescope is on the ground, having to deal with the pesky atmosphere. And both of these images, this is why I selected, is because both of these images show gravitational lensing. So it's you can actually photograph astrophysics or general relativity, right? So gravitational lensing is an effect predicted by Einstein's theory of general relativity, the bending of light from a distant source by the gravity of a massive object in the foreground, such as a galaxy, or in this case, a galaxy cluster. And so Abdur's image shows what can be done combining consumer grade equipment, maybe on the expensive side, but still consumer grade equipment. You combine that with dedication and skill. And so the panel on the right, by the way, I just should mention the arrows are indicating the corresponding gravitationally lensed images of galaxies in both panels. So the image on the right from Abdur represents 20 hours of image capture using an ASI 294 camera. It says bin 2 here in the notes, and on a C11 telescope working at f7. So this is all stacked in PixInsight using fast integration, and I like images that can also show either astrophysics in a single shot, or in this case, general relativity in action. That's why I selected this photo from Abdur.
Yeah, that's a great choice, Luca. Part of what Astro-Imaging Corner has been about all these years is we get such excellent images, and we're all inspired to try harder ourselves to meet the quality of the images that we get. And this is a perfect example. This is something that is a tremendous feat, and it's something that we can all aspire or try to emulate. So AIC works when it inspires others in the club to do better and work harder at their craft. So for 2025, I picked this image of M51 from Brian Martin. He writes, as a good start to galaxy season, here's an image of M51 taken in mid-March and combined with data from 2023, a total of 11 plus hours in LRGB and HA using a ZWO 1600 millimeter camera on a C14 at 2300 millimeters and a custom-made German equatorial. Brian is a frequent contributor of high-quality images to AIC. And M51 is another favorite deep sky target of imagers, and there have been many, many submissions of M51 over the years to AIC. The thing about M51 is it's tiny. And well, here's an image to shoot for. I mean, this was shot with a C14 at no less than 2300 millimeter focal length. And, I think we all know that the longer the focal length, the more difficult it becomes. It's just harder to get good tracking, harder to get good images, and look at this. This is done at 2300 millimeters with the C14. So again, something to shoot for, and an excellent image from our Brian Martin. So that is, we hope you've all enjoyed this anniversary edition of Astro-Imaging Corner. I want to many thanks to my co-hosts, Abdur and Lucas. I know, having done it, that it took quite some time to go through all those images. It was a It was a wonderful thing to do, to look back and go through them, and it wasn't easy to pick the ones that we picked. And I also want to say a sincere thank you to the many, many contributors to AIC since 2009. I think the Edmonton Center's Astro-Imagers and Sketchers are second to none. So onwards and upwards, and especially clear skies.
Thank you, everyone. Those were fantastic images. Okay, we're almost to the end. We'll get the trivia answer, final announcements, which is not many. Okay, there are the answers. The only planet not named after a god is our home here on Earth. Coldest place in the universe, the Boomerang Nebula. And you think I could find that anywhere? No. Which planet do not have a natural satellite? Mercury and Venus. And the unit of measurement to describe the expansion of the universe, that's the Hubble constant. Okay, Frank, we'll go to final announcements. Cartoon. Kind of made sense to me because just read yesterday that the Voyager 1 spacecraft next November will be exactly 1 light day away from Earth, which is 26 billion kilometers. And it also is carrying the gold disc that had the information about what humans look like, a mixtape, and directions how to find it. So I thought that was a fairly good cartoon for this, from what I read yesterday. Okay, final announcements. Next Monday is next meeting is December the 8th at 7:30, and I think we have somebody lined up for that. I think Sharon got somebody already in line for that. But keep an eye on the website, and there'll be more information there. So with that, we'll call it a night at 9:47. And thank you for all attending in person and online. And I think everybody should get a good round of applause for that 150th anniversary. Okay, thank you and good night.